Welcome to Longevity and Aging series. Today I would like to introduce to you Dr. Yu-Xuan Lyu. Yu-Xuan is a research assistant professor in Southern University of Science and Technology in China, and he focuses his research on mTOR signaling and autophagy. Yu-Xuan is a co-author of a recently published review titled Longevity Biotechnology, Bridging AI, Biomarkers, Geroscience, and Clinical Applications for Healthy Longevity. This review summarizes the latest developments in longevity biotechnology presented and discussed at Aging Research and Drug Discovery meeting in 2023. So Yu-Xuan, over to you. Maybe you will give more detailed introduction of yourself and your research focuses.
Thanks a lot. That is it's very amazing to have this opportunity. So as you already introduced myself, that I'm currently a research assistant professor at the Institute of Advanced Biotechnology at Southern University of Science and Technology. So it's very hard to pronounce it, but basically it's the SUS Tech. So in China. So the place is in Shenzhen, so a city very close to Hong Kong, and now you might also heard about like the DJI or Huawei. So those company actually comes from Shenzhen. So that's just give you an overview that where I am and why I'm working on that. But beyond that, I'm also serve as a lecturer at the Geneva College of Longevity Science in Switzerland. So that is one of the reason why I take this position is because I think there's two main reasons. So first reason is I was formerly working as a researcher at the Max Planck Institute for the Biology of Aging in Germany. So that's one of the most advanced basic fundamental research institute on aging and longevity, right? And the second is that I'm very keen to push the longevity education, because I believe that the longevity, if we are going to, in the future, if we can use aging research and also longevity medicine to apply to the human or translational applications. So technology is something very important. We're going to talk about more in detail today, but also the education are also kind of like I think is very important, especially we need to create a dialogue between our researcher and as well as the people who actually would like to understand what the longevity research or longevity medicine means and what actually they can benefit from that. So that is one of the reasons I take this position. And beyond that, I think as you already give a very nice introduction. So I'm focused on the mTOR autophagy signaling cascade, and especially on the sex differences of aging and pharmacological interventions. So my formal work in the Max Planck is mainly focused on rapamycin. So one of this kind of like we call that the geroprotective drugs. We hope that they actually can also apply to the human in the near future. But now when I move back to China, we're also trying to find more nice no matter whether it's supplement or drugs or even another more fancy advanced technology can try to extend the health span and as well as the lifespan in humans. Yeah, so that's my kind of short introduction. Thank you.
Great. So this paper, this review recently published, is basically summarizing the state of the field in longevity biotechnology. So can you please give a brief overview of this and maybe main technologies which are driving the field?
Yeah, thanks a lot. So it's very glad to share this reviews. So basically, if we look into the title, I think we can already see that this paper is mainly trying to getting the current or the much modern advance of AI. So that's one of the very important things in the field at the moment, as well as geroscience and also some technology as well as how to say that this longevity medicine. So mainly like the clinical application. So we're trying to combine the AI, geroscience, and the biomarker and as well as this life medicine, sorry, not the life medicine, but longevity medicine, trying to combine together and see how actually we can create ecosystem for longevity technology. Because I think the most important at the moment is that we already have quite a lot of advantage, also the knowledge in different category, right? Like the AI, now we have the ChatGPT, and as well as we can actually use AI to do the drug discovery, which we might talk about this later. But how actually AI can benefit the healthcare and also find out the drug which can benefit the age-related disease. So that is something actually we need to not only look into the AI, but also the geroscience, because geroscience basically provide you the basic mechanistic of aging, right? So what the aging is and how actually we get old and how actually we can actually extend our health span. So all these mechanistic things, the biological mechanisms, I think that is something actually we need to understand before we can combine with AI, and as well as the longevity medicine. Nowadays, we call it this more like a prevention medicine, because we do believe that if we're going to slow down or even compress the age-related disease, we can not only use the current model of a medicine, which is we first have a disease and then we use the drug to treat that, right? We know that if we can actually find out the best time window early on, then actually we can imply some of the intervention, so which somehow we can actually prevent the age-related disease and also extend our health span. So that is, this paper is trying to combine or kind of like trying to harmonize all everything, which is, I think, important for the longevity in humans. Thank you.
Definitely. And you also mentioned the omics, comprehensive omics and innovative aging clocks, right? So which also include some AI technologies. So if you start talking about AI as the main driver of biotechnology in longevity, when it's applied to drug discovery, can you give some overview of that? How is it used in drug discovery, and what is the most important parts in the pipeline which could be solved using AI?
Okay, thanks a lot. I think that is I mean, when we talk about the AI, it's a huge, right? So I trying to pick up some of the things which I believe is most important for extend our health, I mean, healthy longevity, right? So for one of the key thing we find out at the moment is that we can apply AI to accelerate the drug discovery. So that is something we cannot achieve, I mean, maybe 10 or 20 years ago. So that is something actually is important. So one of the things we found out, like AI can accelerate, especially the early stage of drug discovery at the moment. So in the past decades, when we look into this drug pipeline, right, we might need to spend 2 to 3 years for the early stage drug discovery from finding the target and then to validate the target and also find the hits, right? And then we find the lead, and then we start and do this preclinical animal test and so on. But now the AI actually can help us to compress this stage from 2 to 3 years and then maybe to 2 to 3 months. So that's very impressive, because I think there's a few examples, including one of our last authors, Alex companies, and in silico. So actually he published, I think his company published at least 2 very important papers this year. Last year, basically, in 2024. So they found out that the AI can actually really empower the early stage drug discovery to shorten the time. And then also maybe this shortened time can actually cure a lot of things, because I mean, this is one of the challenge in the drug discovery, that is we take too much time at the early stage before actually we can get into the clinic. So that is one of the example. I think, and then the second example, I think I can also tell you that it is something actually can combine the AI with the omics. So the omics is one thing I think is very powerful because I mean because the omic can tell us not only one point, right? It's a multiple informations that can systematically, I mean, describe our bodies or maybe there's kind of like a disease or somehow the aging information. But the omics also have a problem because our brain, I mean, at least, I mean, my brain is not able to handle too many information at the same times. So AI gets in, right? The AI can help us to digest the information from the omics and then show us the most important information. So that is much easier for not only the researcher, but also for the physician who actually in the future can actually use the AI to understand the omics and use some of the omic data to identify the most important biomarkers of aging and also can show how can use this thing to apply the most probable anti-aging or maybe geroprotective therapy or interventions. So I think that is a few of the case I can tell you that what AI actually can do. But I believe that the AI can do much more, right? So nowadays I also use AI in a daily basis help me to understand to trace to follow the most recent scientific finding as well as help me to also polish some writing. I think that's something actually AI is incredible. That's what I would say. Thank you.
And do you use AI at your lab to? You said you're looking for geroprotectors, so more to other substances which could extend lifespan. Do you use AI in your lab, and if you use, how do you do this?
Yes, thank you. I think that's a very good question. So we are at the very early stage because I just started my lab earlier this year. So earlier last year. So basically just I'm going to have my 1 year's lab establishment anniversary in next week. But yeah, so I actually start to using the AI. So basically like this um, uh, deep learning algorithm to trying to understand trying to understand the differences between the compounds as well as trying to analyze the image because one of our current projects, so one of our project at the moment we're trying to build up the high throughput animal yeah, in my lab, so we are using AI at the moment, mainly for two reasons. So first is trying to screen the drug library because I think that is somehow that we do have a lot of compounds, but we cannot do all the screening, right? To do the aging related experiments. So we trying to use AI to give the hints that okay, can you just give us some of the drugs that has potentially target maybe this signaling like the mTOR or autophagy. So AI can does very good job because they basically just do the screen, right? And also trying to find out the literature behind that. So that is the one thing. The second thing is that because our lab also starting to establish high throughput animal-based drug screening platform. So something similar to like the Wormbot, I think Metcapeline and I think Oral Biomedical and also a couple of companies using start to establish those things in C. elegans. So we do it in fruit flies. So because we believe fruit fly can provide something
Oh,
unique information compared to the C. elegans,
mhm.
but nevertheless, all those high throughput things, animal based, is basically you have to connect a lot of image and video, right? And
Mhm.
because it's behavior based, so this AI is very powerful, can help us to identify, I mean, what the behavior and what the response, I mean, would be have the potential to can be used as a potential indicator to show that those intervention, for instance, like a drug A or drug B can have some beneficial effect to the animals. So that is the second thing, and I think this would be very powerful because I mean, when we look back maybe 10 or 5 years ago, we cannot, so we don't see any small animal can be used for drug screening, because basically usually we just use the cell base and then we jump into the mice, because the cell base is much easier to analyze then, right? But
Yeah.
nowadays, because we have AI, so we can actually see a lot of company or also researchers start to use that small animal, because we see there's some um, advantage to using small animal, especially the animal which live relatively short, because then we can actually test the compounds to see if they can extend the health span, but also the lifespan in several weeks or maybe several months, which I think in the future, actually we can also accelerate the drugs which can use for age to against aging or against age-related disease much quicker than before. Yeah.
Mhm. And you mentioned that you're doing some screens on Drosophila, which is quite interesting. And to be honest, personally, I never heard of any screens on Drosophila in automated way. Like, are you aware of any other competitors in this field? Or
They,
and the other question
mm,
is, what kind of diseases, or what kind of drugs do you think Drosophila would fit better?
Okay, that's a very good question. So thank you. And so first, I think there are not many competitor. I think the reason for that is that because Drosophila is, even though it's very, I mean, very well known animal model, right? The animal model in research field, but there's not many people using them to do the drug screening specific for anti-aging or maybe aging research. And we do this because, first of all, I work with flies, I think more than 7 years. So I do understand flies. And I also have a chance to work with C. elegans. So I do know that they do have a different advantage in that sense. So for Drosophila, so there's something I think is a bit outperformance to the C. elegans. Is because they do have I mean, two sex, right? The natural. So they have male and females. And we also see that there's a lot of intervention, including the rapamycin and spermidine, which I perform. And they show the significant sex differences. This is somehow actually a mimic what the mice show, that at least in mice, including like the ITP experiment, we do see that rapamycin will have a greater impact on the lifespan on female compared to males. So that is something also we also see. So I think that's the first thing, because they do have a natural two sexes. And the second thing is that Drosophila, they do have the adult stem cells. So we know that if we look into the hallmark of aging, so one of the hallmarks is a stem cell exhaustion, right? And that is something actually Drosophila can actually do much greater job if we want to look into how the stem cell renewal and how the stem cell can somehow connected to each others. And the only drawback I have to say that, or maybe two drawbacks, let's say compared to C. elegans. First, as the adult of Drosophila is not transparent. So if we want to do kind of fluorescence, you need to find a way to do that. But we already trying to establish that the fluorescence-based experiments. So far looks very nice. We can able to catch up. So that is also somehow benefit by the AI, because the AI actually can they have a better, they can do very good job to remove the noise, and catch the real signal. So that's first thing. And the second thing is that I think Drosophila live a little bit longer than the C. elegans. And if we're going to just do the lifespan screening, so that is, of course, I think C. elegans is far more better. But on the other hand, nowadays, I think the people are more keen to look into the health span rather than lifespan, because we know that live healthier is much important than only live longer, right? And Drosophila, because they are more comprehensive in the sense they have a legs, they have a brain, they also have a kind of like gut, and also they have a heart. So then you can actually create more behavior-based measurements, including like the sleep. So I think Drosophila also they have kind of very nice sleep curve,
Mhm.
similar to the mice. So I think that's something actually we can achieve. We can get more information when we do the Drosophila. Yeah, so I think that is one of the reason I think I will use Drosophila. But I think that's also nice that we get a lot of very nice support from the people using C. elegans to tell us that okay, this directions should be very promising and we should just keep going. So thank you.
Well, I would only mention that in C. elegans you also can potentially study diseases because they actually have age-related diseases too.
Exactly, sure, of course. I think that is one thing, and we also need to appreciate that those small, tiny animals can do a lot of things. And also one thing I would like to add, because we already have kind of like a startup project together with some of my former colleagues in the Max Planck Society. So we got support from the Max Planck Innovation, and we hopefully can establish our company later this year. That's what I will have. I need to check with our CEOs, right? But we also already get some kind of financial support to move this project to the real world applications. And we also started to collaborate with one of the biggest CROs in Europe. And I think the current preliminary data using Drosophila to screen drugs, or let's say to measure the toxicity response to the drugs, I think is kind of very nice. So I hope that we actually can use Drosophila to do more things, not only the drugs toxicity, but also like the age-related diseases. Thank you.
Oh, amazing. Back to the paper, I I remember you mentioned one of the papers from Alex, and he has a paper with so-called dual approach when they simultaneously target particular disease but also some age-related pathways. So, do you think this approach would help to establish aging as a disease and help some to get some regulatory approvals?
Yeah, I think it's a very smart way to deal with this, and because one of the burdens, I mean the one of the biggest burden to dis to find a drug or find a therapeutic way to target aging is because the aging is not a disease. So I mean, so no one's there to actually push this forward to invest the drugs target aging, only target aging because they might not able to get approval and then they lose a lot of billions of dollars, right? And I think the dual approach is very nice, and because no matter how aging might be defined as a disease or not, I mean, I hope that will happen in the future. But
Mhm.
at the moment, we need to, I mean, follow the current regulatory path. So I think find a way that find a specific target, which is called like maybe cancer or dementia or whatever related to this kind of age-related disease. I think would be very nice way to at least find the drugs can target this, and in the same time, we're also trying to find out whether this drug can actually also have the other potential beneficials like anti-agings. So I think nowadays we also see a lot of the very powerful drugs, right? Can actually do multiple functions, not only one thing, but multiple things. I think the points like um, because for the regulatory agents, I think they're mainly focused on not the mechanisms behind the disease, right? They're more focused on the response for the human, right? If the drug get in, no matter how they goes, as long as you can you can relieve the disease symptoms and also have a kind of like a relative safe profile, and then you get approval.
Mhm.
But for the researcher, we are more focused on the mechanism, right? The mechanism things.
Mhm.
So nowadays we know that the aging and the age-related disease, they have a lot of overlap, including like the cancer. And if you look into the like this clause, I forgot the name of the paper, but basically you also find that the mega hallmarks of aging and cancer, something like that. So we actually found out there's a lot of crosstalk overlapping between like aging and cancer and maybe also like a dementia. So I think if we design drugs target one of those hallmarks, and potentially we can actually one stone hit two birds. So I think that's a very nice approach, like this dual purpose. Thank you.
Yeah, let's move to biomarkers area maybe. So can you share some reflections from the conference about biomarkers?
Yeah, so yeah, thank you. The biomarker is always the I think the one of the hottest topic in the field, right? Since 2013 or whatever, like Stephen Hoover to they launched the first DNA methylation clock and also the biomarker is something also related to that. And nowadays we see a lot of different biomarkers as well as a lot of clocks. So from the DNA methylations and to maybe like a cytokine, almost like a metabolite. So I think the field is going very well, but we still face a lot of burden because most of the biomarker at the moment we collect is more like this how to say the cross-sectional collection, right? We did not able to collect it longitudinal, at least for most of the studies. So we can build correlation, but whether these are causations, we don't know yet. At least for most of us, we cannot say that, okay, this the market change is something actually can reflect your body's change. And I hope maybe in the next 5 years we can actually do more longitudinal study and also powerful with the AI because one of the important things like all this new biomarker we might need to cross check with the old generation or the traditional biomarkers like the glucose in the blood, right? And maybe also the heartbeat and something like that. We need to actually have a kind of a validation between the new generation of biomarker with the old, whether it's kind of outperforming the old generation. If not, then we also have a trouble. Okay, the people say the physician will say, okay, we spend a lot of a lot of money more than before. And then you just tell me, okay, those biomarker, the traditional one and the new one is basically performance state of it. That is also kind of very hard to. We need to have a very nice study and maybe not only one study but multiple study to prove that the biomarker, which is something linked to the can actually indicate your health perspective, but as well as maybe it also have outperformance compared to the traditional one. So I think it's very promising at the moment, but we still need some time to actually to use about those omic based or whatever biomarkers to in the clinic settings. Thank you.
So basically, we need to relate some agent biomarkers to some clinical outcomes to prove that they're actually showing something meaningful.
Yeah, so I think that's nowadays if you're going to like this there's several setting. I think it's kind of promising. One of things like the time trial. So I have to mention the time trial because we all know that the time trial is very important, and because it also include the biomarker. And as long as we can see that, so one of the kind of the promising geroprotective intervention can not only extend your health span, decrease your age-related disease potentials, age-related disease chance, as well as to change your biomarkers. And I think that is something actually you can start to telling that, okay, maybe that is some kind of correlation between the biomarkers and the geroprotective intervention, and as well as your biology of aging. So we do need such clinical setting or clinical trial to prove that. So thank you.
And talking about clinical trials, what would be the main challenge for them? Like, do we have um, a right idea about the targeted population? Should it be younger people or older people? or sick people, like people who already pass the optimal treatment window. So is there any proper discussion on that in the field?
Okay, thanks. I think at the moment, I don't think we have kind of like a we do have a lot of discussion. That's I have to say that, but I don't think we have a kind of like agreement to say that which setting would be the best, because aging is we still don't have the clear definition of when the aging started. I think recently there's a paper published. They collect they did a survey in one of the, I think it's in the Golden Conference in 2022, if I remember correctly. So they show that even in the aging field, the researcher will have different researchers will have different ideas when the aging starts. So some people believe start since you arrive in the world, right? So start very early, and some people believe after 20 or 25 years old. So
Mhm.
that is, I think if there's no definition of when the aging start or what when, so I don't think we will have a very clear definition or the groups to find out how we can use aging or sorry, how we can try to start aging intervention to a specific group. So, but we do see that different country or different regions, um, I mean, use intervention to help the people. So that's including like a dietary supplement, including some of the small molecule drugs,
Mhm.
as well as some people actually using the stem cell or maybe the cells this gene therapy. So even though there's a very small cohort, but we do see that people are trying to take I don't know whether it's to take the risk, but as some people trying to be a biohackers and trying to use those approach to prove themselves. And we do see that many of these people are around maybe after 35 years or after 40 years old, and then something between 35 to 60s or 65s.
Mhm.
So that is some kind of like a middle-aged people. I think is the people are there to because I think during those region during this age range, the people usually they are already knowledgeable. They can take their own responsibility, right? And they also relatively healthy, and they would like to take some kind of like a very unprovoked interventions, let's say like that. So I think that might be the target groups for the most advanced aging interventions, maybe for the middle-aged people. So, but that's just my conception, and that's what I see. But
Mhm.
I do have a survey which I'm going to share maybe next week in this NUS healthy longevity webinar. So we did a survey in China, and we found that the people who are actually the age group who are most interested in anti-aging, or let's say the age-related or aging interventions, are middle age groups from 35 to 55, something like that. So thank you.
Great. Yu-Xuan, part of your review was about longevity medicine. Can you just summarize and give some introduction to this new field?
Yeah, so thanks a lot. And so longevity medicine, just my opinion, I think is a very nice way to, it's kind of like a redefine the prevention medicine as well as the personalized medicines. And because longevity in medicine is mainly focused on the healthy agings. So I think that's the first things. And the longevity medicine doesn't like the current medicines in the hospital, right? Because you most of the medicine at the moment, like if you go to the hospital and then one of the medicine or one of the physician will take you to the do the exam and give you the treatments, right? So the current medicine is basically if you have a disease, if you are sick, and then you go to the hospital or whatever clinic, and then the medicine can help you or treat you and cure your disease. So the current medicine. But for the longevity medicine, it's more like a prevention as well as the personalized medicines, because a longevity medicine is something more advanced in terms of like before you get the disease, as long as you are getting old or maybe have somehow like a age-related disease or disorder, and in the futures, the longevity medicine kicks in. They help you to change your maybe not only the lifestyle, but also maybe use some intervention, including supplements, drugs, as well as maybe some other possibility way to actually to help you to maintain your health stage. So the longevity medicine is not the medicine give you a pill or maybe to cure your disease, but rather trying to prevent your age-related disease. And also, I think that is the first thing. The second thing is like longevity medicine is a very personalized medicine. So that is one of the reason longevity medicine somehow is very endorsed or empowered by the AI, because the AI actually can help us to do a lot of things, including the personalized approach. So I think, and these two things is a very important aspect for the longevity medicine, the prevention and personalized. Thank you.
Mhm. And well, obviously, this creates some challenges because um, at the moment, even current responsive um medicine is quite expensive, so becoming more complex. So if you include uh, more preventative approach, but we'll use aging clocks and various diagnostic tests combined with AI, it might create some danger that it will be available only for only rich people. So yeah, do you think it could be possible to make longevity medicine available to wider population?
Yeah, I think that's a very good question. So I think that's always a hot topic or debate in the field that and not only longevity medicine, but also apply to the other more advanced approach. So I think you might be right at the moment, because if we're going to combine like this omic, the AI, and also all these advanced things, the cost is kind of like, unacceptable for the ordinary people, right? But if you I think, but if you look into what the like the cell phone, I mean, revolution, or even like computer revolution, right? I mean, at the very beginning, only the rich people can use the cell phone, despite that at that moment it's a very huge cell phone. We even don't call the cell phone at that moment. But just after a few years, I mean, the price is directly drop, because people see that is very useful and actually can help the people. So I don't think is issues in the near future, because you can see the AI revolution is crazy, right? Maybe 2 years ago we cannot even talk about, maybe we cannot even believe that okay, there's a chat GPT comes in, and now we only need to pay couple bucks, and then we already can use the very most advanced chat GPT can help us to do a lot of jobs. So maybe at the very beginning, or actually at this moment, longevity medicine is still a bit relatively expensive, I have to admit. But after maybe 2 or 3 or even 5 years, and I think they will be dropped crazily, and most of the people actually should be able to afford that. So that's my perception. Thank you.
Thank you. Um, Great. So, what do you think the main challenges for longevity medicine exist at the moment, or
Yes.
barriers? Maybe you see them in China at least.
Yeah, I think that's so one of the things for the longevity medicine, the challenge. I think the challenge I have, yeah, I think the first challenge is somehow the perceptions, because it's called medicine, but actually is not the traditional medicine. So as I mentioned, that's more preventive things. So and all the people, at least for most of the people in the public, we believe that we already have a kind of concept when the medicine is going to cure a disease. But aging is not a disease, or a prevention is something we cannot cure something before we have them. So I think that is the one of the challenge you need to let the people understand. Okay, longevity is something actually can help you to prevent some risk, some age-related risk in the futures. So we might need to take a different approach compared to the current medicine to educate the people and also try to talk to them to let them believe, okay, I'm not going to trick you because if the people think that, okay, I don't have anything, why I should buy, why I should do the longevity medicine. So I think this is kind of like the concept, the mindset need to change. And the second thing, as you mentioned, because it's prevention medicines and for most of the longevity or health related indicator is very hard to catch at the very early stage. I mean, at the late stage, like this current medicine, we only know that we have all the biomarkers to show that okay, you are disease, you have a disease because we have those indicator, right? But for the longevity medicine, because we do not very understand and what the aging is, and we don't at the moment we don't have a very powerful, or let's say the biomarker actually can already apply in the clinic settings. So that create a lot of trouble. That's how we can define whether you are at a health stage or maybe you might have a risk in the near future. Maybe after a couple of years, you might have some risk. So now you need to start with the longevity medicine. So I think that is a lot of things we need to still need to solve before we can actually to convince the ordinary people or lay public to use the longevity medicine. Thank you.
Great. And for this conference, can you share any main breakthroughs, or do you believe there are any technologies or interventions which are closer to translation in clinical practice?
Thanks. So there were quite a lot of wow technology breakthrough. So I cannot name all of them. So that's I have to admit of that. But in my opinion, I think one of the cool thing I believe can be used in the clinic in a relative quick is the kind of like this inflammation, the anti-inflammatory treatment, like no matter like this IL-11 um, way to trying to inhibit, sorry, anyway, trying to modulate this chronic inflammation can actually do a lot of benefit, to create a lot of benefit to extend your health span, but also decrease a lot of risk in terms of like the autoimmune disease as well as the other disease, something that's will happen during when you get old. So I think that is something should be relatively easy because the immunity, the inflammation is something is kind of a relatively well established in the clinic setting. So we know that if we look into cytokines, right, like the IL-6 or IL-10, the change is something we do know that is something related to your health status. So nowadays, if we actually trying to find a drug or compounds, let's say like trying to balance those change, especially during when you're getting old. And I think that would be very useful and very powerful to apply into the clinic settings. Thank you.
Um, and another question what I would like to ask you is, um, do we have any particular main challenges with regulatory approvals at the moment for these interventions? Because as I understand, there are no biomarker or intervention which is approved. What will be the shortest path to this?
Okay, very good question. Very good point. I think I have to tell you that initially when I moved back to China, initially I want to start to work on this drug intervention similar like a rapamycin, right, in China. And then I found there's no investor interested in that because they go, okay, it's a very long path. I'm not going to do that. Maybe because it's China, it's not United States. United States, maybe they have a much understanding how to invest a drug to fight against aging. So that is a different story. So if I particularly talk about something happening in China or maybe in the rest of the world, we found that actually the people are more keen to go into the no regulatory territory to find the compounds that can against aging. So at the moment, we're trying to put more weight on the supplement. Despite that, so we do know that supplement is not very nice in the field that they do not believe supplement can be useful because because they do have a kind of regulations. But we do know that at the moment, if we talk about some geroprotective compounds, at least in the preclinical animal testing, we do know that including like the the NR or NN, they somehow they show some benefits, not all, but at least they show some benefit for some age-related disorders as well as the AKG and spermidines and also a lot of new things, right? And we also see that some company, including like the Nestle and also the other this supplement or nutrition company, they do put a lot of effort to find a new compound to go for these ways. So that is also one of my focus at the moment, trying to collaborate with a nutricellular company to trying to find out if we can actually find the compounds that's not going to treat the disease or treat age-related disease, let's say like that, but we are just trying to improve and also slow down your age-related disorders. And then we find a compound, which we call supplements, can do something. I know that is not the perfect way, but at least I think that's kind of a shortcut at the moment.
And it's first step, at least, right?
Yeah.
Okay, and maybe the last question is about governmental institutional in steps or initiatives. Maybe you know about any of them in the field.
You mean the like government oriented initiative, right?
Yeah, like any. Do you know of any initiatives from government or maybe some institutions which
So
do
okay, so I think there are some. So one of the big
on the population level, because government operate on the population level, like do they have any initiatives? For example, I know that in the UK they establish an trusted research environments to keep the records, medical records for the whole population, and I think there is an idea to use them for longevity. Maybe you are aware of anything like that in China.
Yeah,
Anything?
we do have. Yeah, I think we do have something happening in China, but as well, I think as well as the other countries, like this longitudinal aging cohort. I think our government started at least in China, we all started to put a lot of money on to do run this longitudinal research, collecting like this blood samples and time to time to describe actually to find out what biomarker would be very can be useful for indicate the aging process or age-related disease process, let's say like that. And we do know that the UK Biobank, for instance, that actually is very powerful for aging study as well as some disease studies. So, and in China, I think also in the rest of Europe and also the other countries, we also started to collecting those things, particularly like the blood sample, and also some people were collecting the stool, the pool sample for the gut microbiomes as analysis. So those things I think would be very powerful and useful. But of course, because it's a longitudinal study and we were not able to have all the data right in the days, right? We still need to wait for several years to until we can actually find this out. But yeah, I think we actually moving in a very good direction too. collect those data. So I think that's something we should appreciate.
Cool. And well, so the last question is, you mentioned in the review something about decentralized science and some new approaches for funding. Can you just elaborate on that?
Yeah, so sure. I think that's very important, and we see that a lot. We see some of the decentralized science funder like the Vita DAO, for instance, and also a lot of the DAOs, as well as some cloud fund to support the clinical research, including like the rapamycin, I think, and as well as the metformin and also the other things because at the moment, as I said, because aging is not a disease, so finding using a drug to treat aging is something. I mean, there's no investor willing to pay for that, and also the government setting, maybe they believe that this is more clinical study, and so they usually only fund the fundamental study, right? They are not fund the clinical study, so they create a huge gap to move the clinical or translational research forward. So I think this cloud fund and also the all the other decentralized science I think is very useful to actually move this field forward. And I think somehow I also watch like a YouTube video and some people some of those research the mind also trying to say that okay we start another cloud fund and also trying to hold we can collect enough money from the people who are willing to contribute to the aging research and trying to move things forward. And also I also have to mention that, for instance, like this adult aging project, I think is very nice approach that nowadays I think because they lack of the funding from the government, so they also trying to find a way to get some kind of like a cloud fund to support their research. And we also going to start this in China, hopefully this year or maybe next year, that we can also do some kind of things together with the people. So yeah, but we also need to look into the regulations. So maybe because different countries have different regulation in terms of this, but we think yeah, that would be very nice way to move this field forward. Thank you.
Great. Thank you for your expertise. And yeah, I hope our efforts will bring more people to longevity field. And all the best with your research. And hopefully, I'll see new talks from you soon. And maybe see you at next ARDD meeting in 2025.
Sure, of course. Looking forward to see you in Denmark this year.
Cheers. All the best.
Bye.